I'm going to start the recording and then pause it for a second. To prepare for today's lab, you want to go to OneDrive. If you want to follow along, obviously you can just listen like we've done before. And two things I need you to download. First of all, from Unit 5, we're going to modify the compound conditions that we did in Unit 5. Remember there was a quiz in there where you had to pick my two favorite colors, and if you picked more than two, I told you that's no fair. We're going to modify that today. So you can download Compound Conditions 4 and then return to Unit 6 and download the List and Combo Boxes Start. So go ahead and download those. I'll give you a couple minutes and then I'll start. Last time we finished up the regular for loops that use counters, and you did a lab to practice those a little bit. We're going to do one more of those. They tend to pop up frequently. All right, so we'll do another one today, but what we're going to be focusing on today is the ForEach loop. I'm going to be bouncing around a little bit in my notes because I've modified the examples a little bit. So I'll be bouncing around. We'll be talking about ForEach loops and combo boxes and list boxes kind of all blended together, but I think it'll work just fine. Please, there we go. The ForEach loop is like a counter control loop, except it's even more automated. Programmers who are building programming languages have discovered that we so often start at the beginning of the list, go to the end. We often have a large list of things to process. Today we're going to generate a list of random numbers, and we're going to want to process them one to the end. We could use a regular ForEach or a regular for loop to do that, but a ForEach loop simplifies the process even more. In the future, in Programming Logic Intermediate, we're going to access databases, and we're going to ask the database to send us a list of all the students who are in the 4 o'clock class. And then I want to process those. I'm going to start with the first student and go to the last student. I don't usually start at the end and go to the beginning. I don't usually start in the middle. I don't usually skip every other student. If I want to, I can, but then I have to use the counter control loop. More often than not, we start at the beginning, go to the end. Next one. So notice the for loop flowchart symbol has gotten a little simpler. Start at the first item, whatever it is. You don't hardly even have to change that. If you want, you could say first student. More students, yes, keep going. Go to the next student, go to the next student, go to the next student until you're done. Notice there's no counters for us to control here. We just go to the next one, to the next one, to the next one. And the for loop itself is also a little simpler to write. Now before I talk about that too much more, I'm going to back up just a smidge here and talk about object variables. We've already seen these, you've been using them. Not everything's an integer, a double, a string, a boolean. In your welcome screen, when you link to that, you declared a variable of type form. I hate to call it a type. Its class is form. We processed radio buttons. Remember in your Unit 4 program, or 5 program, simple subs, and in your programs, we created an event handler that handles all the radio buttons, but we needed to know which one was it. So we defined a variable called RDO name or RDO, and we said, translate that into a radio button. So you can create objects or variables of any type, not just the primary types or the built-in types, but also predefined types like forms and radio buttons. Now, if I define a variable called RDO of type radio button, I cannot try to link this to an integer, to a label, to a form. It can only assume the properties of a radio button. Sometimes, in one of our examples, we'll need this. We need something that's a little more generic. C# and most other languages have a type called control. Now, in other languages, it has different names. C# has a control type. A control type can be used to point to any kind of control, labels, text boxes, radio buttons, checkboxes, any kind of control. So it's a little more generic. Can't do much with it. We can't check a control to see if it's checked, because if it's a label, that doesn't make any sense. We can't check the image because the object may not be an image, may not have an image property. But it does let us loop And so we can define variables, CTL control, that's just a variable name. of type control. There's one other type that's even more generic than this, and that's the object type. And that's so generic that you can't hardly do anything with it. We've seen a couple of object types as well. What we use those for, we'll see in our examples. But we will often write a for loop, a for each loop, that says, for every control on my form, for every control in this group box, touch it and do something to it. So we're going to use those object types in a few of our for each loops. In general, a for each loop looks like this. For each, that's one word, no spaces. It's a keyword. And again, this is one thing that every language does differently. I have a cheat sheet at home that lists the different styles in at least 4 different languages. I think it's 4 right now, of how to do for in or for each. JavaScript, it's called for in. I happen to know because we just worked on it. Swift, I think, uses for and doesn't even use an each or an in, it's just for. So every language does this a little different, but all of the new languages have a for each loop. And again, remember that means start at the beginning, go to the end. You need to do something different than beginning to end, then you have to use a regular for loop. So the first thing we need to designate, just like before, is what type of object are we looping through. This could be control. This could be radio button. Could also be integer. And then instead of a counter, we have an object variable that points to the current one that I'm looking at. So let me open up one of these projects here just so I have something to talk about. We're going to start with the compound conditions one. So if you want to open that up, you can. And I'm going to go to the form. And what I can do is write a for loop that says for every one of the checkboxes in here, go through them. This loop control variable, this object variable, is no longer a counter. It's a pointer is the way I think of it. It points to the current object. And then every time to the loop, we go to the next one. So in this, it might start here. And that control, that loop counter, points to this checkbox. Then it'll point to this checkbox. Then it'll point to this checkbox. Every time we go through the loop, it points to a different checkbox. And then the next one, and then the next one, and the next one, until it runs out of controls. So we're going to modify this. Remember, we had to count how many checkboxes were listed? It took us 6 lines of code, and if there'd been 15 checkboxes, it would have been 15 lines of code. We're going to do it in 2, regardless of how many checkboxes there are. Maybe a little bit more. There's a twist here, unfortunately. Okay. So in a for each statement, we first pick the type, then just a variable for the name of that pointer. What are we going to call it? Checkbox, radio button, value, whatever we want to call it. It's just a variable name. In, and then collection is generic. That depends on where you want to look. A collection is a whole bunch of stuff put together under the same name. These are all inside of a group box. So I can talk about all the things inside of a group box. Some of you have some programming experience. For you, you might know about arrays. An array in most languages is called a collection. It's a bunch of things all with the same name, bunch of values all with the same name. We're going to see some of those with list boxes and combo boxes. But this collection is just a whole bunch of things that we can walk through with our for each loop. I think talking about it, I'm confusing you. So let's go do it. Let's go into this program and let's recode how we count these checkboxes. So I'm going to go into button check and make that a little bigger so you can see what I'm doing. And here's the code that counts them, 6 lines. And again, if we had 15 checkboxes, I'd need 15 lines of code. I'm going to highlight those and comment them up. When we're counting, do we really care about the order that we count them in? Is it pink? Is it white? Is it red? Is it blue? Not when we're counting. We do later. Did they pick the right ones? But all I'm doing here is counting how many checkboxes are checked so that if they pick too many, I can tell them no fair, no cheating, and stop. What I really want to do is go through every checkbox in that group box and count it if it's checked. Go to this one. Are you checked? Yes. Bump the counter up. Are you checked? No. Are you checked? Yes. Bump the counter up. So we're still going to be doing this count plus plus, but we're going to use a for loop to walk through every one of the objects. In order to do that, however, there's one thing we need to change. Select the group box itself. We need to give it a name because we're going to refer to it in code now. It's called group box 7. That's pretty lame. So let's call it GRP is my prefix, MAE, all caps. Don't usually do that, but I think I'll do it here for multiple and example. It's the group box for this one. I could make those lowercase, but I think I'll leave it today. Plus, that's my stepdaughter's name, so now she'll be impressed if she ever listens to this recording. I doubt it. Not into programming. So our group box now has a name. Back to the code. What I want to do is walk through every checkbox in that group box and see if it's checked. So let's write an if statement, a for each statement. For each. Just like the other four statements, we need parentheses around the conditions of the loop. Each one of the things I'm looking at inside that group box is a checkbox. That's an object type, right? We just talked about those. What do I want to call them? How about CHKBox? That's just my variable name. You can pick any name for that you want. And this says, for each checkbox, while you're looking at it, call it checkbox. We're going to look at them one at a time. And that pointer is just going to move. And that pointer is always referring to the current checkbox. But where are those checkboxes? In my group box. Not good enough. A group box is not a bunch of controls. Remember collection I just talked about? A group box is just a box. But inside that group box, there are controls. Inside the group box, there are controls. And what this says is for every checkbox in the list of controls in my group box, for every one of those, do something. So once again, I now have called this loop pointer. And for the recording's purposes, I'm holding my finger up. Hopefully you can remember me doing that in class. It's a pointer. It's going to start out somewhere. I really don't know where. Maybe it's based on the tab order. Maybe it's based on the order I created these things. I don't know. And the good news is, in this case, I don't care. I don't care if it counts them this way, that way, sideways, inside and out. It's going to touch each and every one of these. What I mean by touch is it's going to point to it. When my loop first starts, let's pretend it points to red. Checkbox is now pointing, is an alias for, is a nickname for RDO red. I'm sorry, check red. And then when I hit the bottom of the loop says, go to the next one. All right, I don't know where that is, but let's pretend it's white. Now the pointer points to that checkbox. So it moves. But we can refer to it as we go through. So remember that checkbox, my variable, my loop variable, points to something different every time through the loop. What do we want to do? We want to see if the checkbox is checked. If it's checked, what do we want to do? Bump up the counter. Notice that my counter is initialized here. So I left the count equals 0 up here to designate that I have initialized my counter. And now this is going to go through and touch every checkbox. If the checkbox is checked, notice I'm referring to my pointer here. It's here. Is that one checked? Yes, count it. Go to the next one. Is that one checked? Yes, count it. That one, yes, count it. That one, no. Doesn't do anything if it's not checked. Goes through the pointer automatically. That's the great thing about these for each loops. Automatically goes through and points to one of the objects in the list. I'm going to try it. Don't bother because it doesn't work. Notice this happens when I click the button. So I'm going to check them all and click on check, and my program crashes. What's your problem? Volker said this should work. Well, not quite. Unable to cast, what did that say? Unable to cast from button. Button? What button? To checkbox. What button? This was my question when I was practicing this last hour. What button? Oh, wait a minute. The controls inside of this group box also include a label, a button, and a label. Oh, but we said for each check, I'm sorry, it's not that smart. The for loop is not that smart to say if it's not a checkbox, skip it. Maybe in Visual Studio 2015, we'll get that feature, but right now it's not that smart. So I need to modify my loop. This is why you're paying the big money. It's not a checkbox. It's an object. I'm sorry, a control. Object is too generic. Control. Every one of those, a button, a label, a checkbox, those are all controls. So this is legal. Now I'm going to give it a better name because it's not a checkbox. That's going to confuse me. And now my if statement doesn't quite work anymore. Now remember, a control can be a label, it can be a button, it can be a checkbox, it can be anything. So I can't just say if my control is checked, because labels can't be checked, buttons can't be checked, so I can't do that. What I first have to figure out is, that thing I'm looking at, is it a checkbox? If it's not, I'm going to ignore it, but if it is, then I'm going to look at it. So let's start with that. If my CTRL, and here's the keyword, is a checkbox. I love this. That's so easy to read. That says, if the thing you're looking at right now is a checkbox. In other words, I'm narrowing it down. It's not just a control, it's a specific type of control. It's a checkbox. If it is a checkbox, then we first need to typecast it because it's not a control anymore. We've narrowed it down. We know it's a checkbox. So I'm going to say, what am I going to say here? You know what? You've been at it long enough. Let's get tricky. If it's a checkbox and it's checked, that's what I would love to say. But there's no check there because controls are too generic. But that makes sense, right? If it's a checkbox and it's checked, then count it. And remember I can't remember. Short circuiting. If it's not a checkbox, it doesn't try to do this. Because if this is false, it never processes after that, right? Because it's an and condition. If the first one's false, it quits. If it is a checkbox, then let's typecast control as a checkbox. Now I'm telling C#, hey, I know it's a checkbox. I checked it right here. I looked at it. It's a checkbox. Since it's a checkbox, convert it to a checkbox. It's no longer a control. It's more specific. It's a checkbox. And then see if it's checked. In order to see if it's checked, I have to put parentheses around this whole thing. This ought to look somewhat familiar to you because we did the same thing with radio buttons. We didn't have to check them to see if they were radio buttons, but we typecasted it and then asked for its name. If you look at your code, if you look at my code for getting the radio button's name, we took the sender, which was an object, right? Because senders are objects, whoa, really generic. And we said, I know it's a radio button. Converted it, and then put parentheses around it and grabbed its name. Here we're doing basically the same thing. Taking that control, telling C#, I know it's a checkbox. See if it's checked. I think that needs to be capitalized. What's going on here? Convert it. And checked. Why is that not right? This one, this one, That's the if statement. If it is a checkbox, and
Do you need that parenthesis before the period of that check?
thank you. Whew. Are you happy yet? Still not happy. If checkbox control, yes I do, or I need it here. Is that where I had it? Yeah, because what that one does is it take this whole thing, which is now a checkbox, and see if it's checked. I think I'm just missing curly brackets here. There we go. Okay, now it's happy. So what does this say? First, check to see if it's a checkbox. If it's not, don't even ask the second question, because if we try to typecast something that's not a checkbox into a checkbox, you saw what happened. It said it can't do that. It can't convert a button into a checkbox. But if it is a checkbox, then go ahead and convert it and let me know if it's checked. If it is, bump up my counter. Since that's a one-liner, I could really get rid of these curly brackets, but I think I'll leave them. And since I'm leaving them, let's label them. This is the end of my if. The indentation definitely helps here, but just in case, this is the end of the for each. So that was a little trickier than I meant it to be. We don't even know if it works yet. Should. Here we go. You can run it now too. I'm going to check all my checkboxes, and it should tell me no fair. No fair. Another thing I could do is let's put a breakpoint in here. When I get to this line, let's stop and take a look at the counter. Take a couple of them out, check. What's my counter? 4. Cool. Maybe we got lucky. Run. Let's make it 3. Check. What do you got now? 3. Cool. Pretty sure it's working. It's counting them. And now just to make sure my program's still functioning, I'm going to turn that breakpoint off. I'm going to go to 2 of them. I got 1, but not both. Uh-oh. You guessed 1. Try again. But there's 3 checked. It should be telling me I cheated. Why is it not telling me that? Count is 3. Should say no fair. Else if, else if, else. Oh, there's another option down here. I think one of these, I think the second option is messing me up. Yep, the second option was what was messing me up. One more time. 1, 2, 3. Check. Count is 3. Run. And it says no fair. That's better. And let's just pick 2, but not the right ones. I got 1. Let's go back to 3. No fair. I got 1. I got both. So the counting still works. If there were 15 checkboxes, you take the same 4 lines of code, and 4 is counting, it's 3, right? Don't count end curly brackets, it's 3. 3 lines of code. If I had 15 checkboxes in there, it'd still work. Now this, as I mentioned, was a little more complicated than I wanted it to be, so let's simplify it. Let's go back to design mode. And what I would like you to do, and remember you have to do a control, command, or command control drag here, is I want to copy that entire group box. So I'm going to select the group box and then command control, and I'm going to drag it down here. So I get a copy of that group box. Now why is this other stuff sitting on top of it? Well, it's actually sitting on top, and I'm going to shrink it down. I got to get rid of some stuff first. First thing I'm going to do is right-click my group box, the new one. I'm going to bring it to the front. When you have multiple objects that are stacked on top of each other, somebody's got to be on top, somebody's got to be behind. I'm going to bring my group to the front. Before I'm done, I'm going to shrink it. This group has a new name, back to group 7, so I'm going to call it group test. GRP test. And then I'm going to delete the label, the button, and the bottom label. I'm going to delete all of those. Yeah, that's a good idea. Now that they're gone, my group box has nothing in it but checkboxes. I'm going to show you that when there's only checkboxes in there, the loop is very easy. So I shrunk that down so it doesn't sit on top of anybody else anymore. Now I'm going to add a button. Could have copied a button, but all those buttons already have code. Remember when you copy a button that has code? It automatically gets linked to the event handler. Automatically. Both things are copied. Ugh. That's not what I want here. I want my own button. Okay, there's the button. Park it down here. Let's call it button clear. That button cannot be inside the group box. If it is, I have the same problem I had before. Now what I have is a group box that has nothing in it but checkboxes. They're all checkboxes. My ForEach loop can walk through all of them without the if statement. Let's code button clear. What do I want this to do? You can skip this part. This method clears all the checkboxes in group test. Again, I want to walk through them in a loop. I could just as easy write 6 commands to say clear those checkboxes, but I want to walk through them with a for loop. Now I'm going to use the ForEach checkbox because I know that each item in there is a checkbox in group test. This is just the type of the pointer. What's it point to? Checkboxes. What are you going to call that pointer? CHKBox. Where are you looking in the group? Can I look on the entire form? You can. You can, oops, I'm sorry. Group test dot controls. You can look on the form. You can say form welcome dot controls. However, this is a big however, it's in the recording, which means you're all going to forget it. However, when you're on the form, this button, this button, this button, this text box are not visible to the form because they're inside of a group box. This form has group box, 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 button. So you can't look inside. Be a little more specific. Button clear. For each one, what I want to do, whatever you're pointing to, Mr. Checkbox, go ahead and set its checked property to false. That's all. So this is going to go through every checkbox and turn it off because CHKBox points to just one of them at a time, then the next one, then the next one, then the next one. Rachel?
Does that work for radio buttons?
It works for radio buttons. It works for anything as long as they're all the same type. If they're not all the same type, then you use this other technique that we used where you say, is it the type I'm looking for? If it is, then do whatever else I want to do to it. One of the examples I've done in the past, I don't know if I'm going to have time because you really don't need it, is clear all the text boxes on a form. In your gas mileage program, there's 100 text boxes, right? We could write a loop, and I think in Programming Logic Intermediate we do it. We could write a loop that goes through all the text boxes and clears them. Cool. Then we could write another loop to clear all the labels. The problem with that is not only does it clear the labels for output, but it also clears all the labels in front of all your text boxes. If you want to know how to solve that problem, January 12th. And $400, please. Okay. I'll show you how to do that. But here, this should work. I now have a little loop that says go through every checkbox in this group box and clear it. And this one shouldn't crash because there's nothing in there but checkboxes. The reason the other one crashed is it hit one of the labels, actually hit the button, and it said, can't do it. I can't turn that into, it's like I can't turn this into a chicken. Can't do it. So it gave up and it gave me an error. But now there's nothing in here but checkboxes. So let's run it. And just to really give it a thorough test, I'll click them all and say go. It's a ForEach loop. So one use of a ForEach loop is to go through a bunch of objects on your form and do something to them. And you can do different things to different objects, if you wish. Now Rachel's question is, can I use that for radio buttons? Sure. And as long as there's nothing but radio buttons inside, which doesn't apply to any of these, but it would to your gas rental program or your belts program, there's nothing in there but radio buttons. Couldn't I clear them by writing a loop? Yes. But isn't it just as easy to turn one on and then turn it right back off again to clear them all? Probably more efficient than writing a loop that says visit each one of them. That takes a little bit of time versus turn you on and turn you off. That's a couple of examples of ForEach loops. Unfortunately, hiding inside a Unit 5 program, so you might write yourself a little note where that's hiding. And now let's go ahead and close that, and I'm going to shift to the list and combo box folder. Inside there, there's a loop statistics folder. That's what we're going to play with first. And maybe last. I'm getting a little concerned that we're running out of time. I really don't want to lecture a lot next week. I want to be done this week if possible. So I might cut a few things out of my examples that I've done in the past. Focusing on what you need for the assignment tracker program. And then more details for the software developers who need it next semester. All right, let's open up Loop Statistics. Loop Statistics is a little program that we're going to write that generates a whole bunch of random numbers and then calculates statistics like sum, average, min, max, those kind of things, range. It's good to know how to calculate those things, because it happens a lot. How often did you do it in Excel? Daily, right? Average, sum, min, max, count, all those things. Well, Excel does it, but there's nothing built into the programming languages to give you a lot of that information. Once again, we have a list size here. How many numbers do you want to generate? I think I initialized that at form load to 50. When we click on new numbers, it generates a new number, but notice that my text box, my scrollable read-only text box is gone. It has now been replaced with a list box. You've seen list boxes before, right? Here's a bunch of choices, scroll through, pick one, or sometimes more than one. In the toolbox, here's the list box. You just double click it and size it, give it a name. That's the one thing I've skipped in this. We don't need to because there's already one here. So I sized it. You don't have to give it a scroll bar. It'll automatically get one if it needs one built into the list box. I use LST for the prefix. I've seen LBX. I use LST for the prefix, and this is a list box. First note that the list box has an items collection. There's that word collection again. A collection is just a whole bunch of things, objects, with the same name. In this case, they're called items. And we can add items to this list box manually. Let's do it real quick. Just go to the collections, hit the dots, and now you get a box. What do you want to put in there? Oh, Volker and Sam and Fred. Good enough. and poof, they're in the list box. This collection currently has 3 items in it. Item number 0, item number 1, and item number 2. You can add as many of these to you as you want. It's an example of a collection. In the old days, Paul would refer to them as arrays. Right? In this case, it's an array of strings. We can put numbers in. No, we can't put numbers in there. The one thing that's a little bizarre about list boxes is they will only hold strings. They will only show you strings. You can put in them whatever you want. They only show you strings. Let's reset that. If you right-click this, I can't reset it, so I guess I'm going to have to go in there and just delete those things. Notice that when the list box is empty, it shows LST numbers. That's not going to appear when we run. That's only there to let us know what it is. When we run the program, that disappears and the list box is empty when we start. What I want to do in this program is take whatever number the user enters in here, and when they click on new numbers, generate 50 or whatever numbers in here, 30, 100, 1,000 new numbers. Oh, that ought to sound familiar. If you've started your enhanced math program, God, I hope so. If you haven't started yet, it's a good time. But in enhanced math, you're supposed to generate 2 random numbers. Well, you don't need a loop for that. Here, I want to generate 50 or 1,000. So I'm going to write a loop to generate my numbers. And I think we can start with that. And then a little later, then we'll figure out whether we want, then we'll figure out how to sort them. Then we'll fill this combo box with some stuff, the statistics. Which statistic do you want? And then we'll show them down here. That's our ultimate goal. So let's start by generating new numbers. Double click on that. And in here, I first want to show you something new that a couple of you have stumbled upon. Int try-parse. Whoa, that takes your try statement and your parse statement and combines them. If you're only getting 1 or 2 things, this works well. If you've got 5 or 6 inputs and any one of them could be screwed up, one big try is probably better the way you're doing it right now. But here, I only have 1 number. So what this says is go to that text box right there and get its text property and try to parse it as an integer. If you're successful, output it to this variable called list size that has to be defined somewhere else first. Notice the keyword out. If you're successful. If this is not successful, we still have a message box, but notice it's in an else clause because we started with an if. So this is not a try catch. This is an if else. Try parse is either true or false. What's interesting is it has a side effect. If it's true, it's successful. It sets this variable. It's a little side effect, all at the same time. So that's new. No requirement for you to use it, but you may if it fits into your life someplace. I want to generate a bunch of random numbers. Uh-oh. Indentation here is, let's see if it works. 1, 2, 3. Nope, I didn't fix the indentation. Let's go to Edit, Advanced Format. That's better. If you press Tab and it doesn't line up, that's because you got an old, this one's still a little crusty. I thought I fixed it. You got an old version of my programs. In the past, I used to set the tabs to 3, so they didn't take up so much room. And I was told that's a bad idea. But some of my sample programs still have 3 character tabs instead of 4. Just align them using Edit, Format, and it'll fix it. All right, I want to generate a bunch of random numbers. How many? Whatever's in list size. I can't use a ForEach loop here because I don't have a pre-existing collection of these things. These random numbers are going to be generated, so I have to use the old-fashioned for loop. For integer n for number equals 1, as long as n is, be one of those days, n is less than or equal to my list size. That list size came from the user. They typed it in the text box. And right here, I parsed it. If the text box has a good number in it, the variable will have the right number in it. And then every time through the loop, bump the counter up by 1. Still a classic loop. We can't use a for each though because the contents, the collection, doesn't already exist. Once this collection of numbers is created by this for loop, now we can use a for each loop to step through it because the collection already exists. So we're going to generate a random number. Here's Volker's tools. So Volker tools is here. We know how to generate a random number. What we don't know how to do is get it into the list box. A list box is not like a text box where there's one big, huge item, bunch of text. It's a bunch of elements in the list. Each one is kind of a separate bar in the list. To add items to a list box, we refer to it by name. List numbers. And you might want to do an add. This is very common, but notice there's no such thing. We want to add to the collection. So we have to talk about the collection, which is called items. In a list box, it's always called items. We can't change that. It's a property. Then we can say .add. And now you can add anything you want. I want to add a random number. vtools.getRandom, and let's go from 0 to 100. Semicolon. So adding items to a list box, not too hard. Each one gets its own row. Volker, I thought you said you can't add anything but strings to it. No, I said it'll only display strings. List boxes magically will convert this to a string. Whatever number we generate, automatically convert it to a string and add it to my list. Let's put an N4 on here so we don't get lost. N4, I don't think so. N4. Just give it a go. $50, that was form load. Put a 50 in there. Go. Cool. Sort of. Change the number to 5. Go. What happened? Tacked them on the end. Just like a text box, if you don't clear it, it doesn't restart this list automatically. Just because I said generate new numbers, I said generate new numbers and add them to the list. If I can just keep clicking this, watch what happens to my scroll bar. It keeps shrinking because it keeps adding more numbers. They're getting added down to the end. We can't see them. We wouldn't recognize them, but they get added to the end. That's not good. So before I generate my numbers here, let's clear out whatever was in there before. I want to clear my list box. List numbers. Dot clear select. No, that's not it. Once again, we're clearing the items. I'm making that mistake on purpose because I do it every year, and you're going to do it. Clear is a method, parentheses, semicolon. Quick test. Generate 50, good. Generate 5, good. Cool. Underneath there, I missed it, there's a sort button. We can sort our numbers and see them from beginning to end. That's cool. Let's sort. There's a button sort, so go back to design view, double click on button sort. This method sorts the numbers in the list box. My first instinct after everything I've learned is list numbers.items.sort. Nope. We're not sorting the items. The list box itself is either sorted or it's not. I think it's sorted. Yep. And that's true or false. It's a Boolean property. That one makes me crazy. Why is the list box sorted, but the items collection is where you add to and remove from and all the rest of that stuff? It is. Let's see if that works. Generate some numbers and sort them. Cool. No, Pam's looking at that going, wait a minute. 114, so that's cool. 2. Wait, what? Why is it 2 here? It's text. It's a string. It's looking at the first characters. I put all the ones together. If there's a tie, use the second character. If there's another tie, use the third character. Then the 2s. There might be a 3 down here. No, there might be a 4. No, 5, 6, 7. Oh, there's a 9. Oh. How do I tell a list box, hey, you got numbers inside? You can't. A list box can only display text. So we have to use programming genius to fix this problem. There's always a way, right? Because we're not asking it to read our minds, so there's a way. We just got to figure it out. Here's my current solution. I'm going to take out the list number. Actually, I'm going to cut it. So it's on my clipboard, so I don't have to type it later. And I notice I already have a handy dandy random number variable. Random number equals this. Go get it. And no need any of the parentheses. Oops, need that one. So I'm going to generate a random number first into a variable, and then add it to the list box. Paste. Man, my indentation's gotten flaky on me. Let's fix that again. It's an error, can't fix it. Okay. We'll fix it later. Add the random number. There, fixed it. Well, that hasn't changed anything, right? I just put it into a variable. So this is going to give me the same effect. It's going to take this is still a number. C#, it's going to turn that into a string and throw it into the list. And when I say sort, it's going to be all confused. I'm going to trick it. Remember our friend string format that everybody hates? I'm going to put 2 spaces. I'm going to format my number in 3 spaces. So if it's a small single-digit number, it's going to appear as space, space, 3. There is no printable character that is numerically ASCII character sequence before the space. Space is number 32, I know that. Everything before the space is non-printable. Tabs and backspaces and carriage returns, new lines, they don't print. So if it's characters like letters and numbers and dashes and decimal point, they're all after the space. So the space comes first. It alphabetizes first. That should solve our problem. So when I add this, as I'm adding it, I'm going to do my trusty dusty string format. I've done so many that I memorized them, but remember they're stuck inside one of those programs. Plus you have plenty of examples. Inside the curly brackets, we always start with a 0, and then how wide do you want it to be? I could make that a 4 or 5 or whatever I want it to be. In case I pick bigger numbers, but my program is generating numbers from 1 to 100, that's it. If I change that, then I can change this. Let's see if that solves the problem. It should. There's my numbers. You can kind of see the space. Notice how they look like they're centered? They're not. There's 2 spaces here, but this is not a monospace font. It's just an Arial or a system font. And so notice they don't line up quite right, but that's okay. They almost look centered. And when I sort them, they look good. 7's at the top. Before, it would have been down with the 70s. Let's generate a new list. Well, that's interesting. Notice they're sorted already. It's a flag that's applied to the list box. As soon as you say from now on you're sorted, that's what it means. From now on, whatever we put in there is sorted. I don't want that. After I sort the numbers, I want the list, if I generate new ones, to be unsorted. This looks completely goofy, but it works. How do you unsort numbers? you shuffle them, right? Well, we don't have a shuffle here. Once the list is sorted, this sorts that command right there, sorts them. And then as soon as that's done, I turn the sorted flag off so that the next time I generate numbers, they're not sorted anymore. But the current list stays sorted. You can't unsort, put them back numbers. You can't put them back the way they were. So let's test that. New numbers, sort them. Cool. New numbers, not sorted. Cool. That works. So there's another example of a for loop. Generates a bunch of numbers up to a number size that the user has provided. And another example is string format, in this case, very necessary so that I can, before it was necessary for analness. Here it's necessary to get my sorted numbers in a list box to actually be sorted. If you want those lined up on the right-hand edge, change the font of the list box to a monospace font and they'll line up. But they look fine to me the way they are today. Let's take a break. When we come back, we'll start generating statistics.